Hi everyone, welcome to Numeriq Learning. In today's video, we will be solving Real Numbers Exemplar NCERT Books Exercise 1.1. Okay, so usually whenever you're preparing for your exams, right? So the minute you complete a chapter, make sure you complete both the NCERT questions, all the exercise problems and the solved examples of both NCERT and Exemplar. Let's start. So this is exercise 1.1. The first question is, for some integers m, every even integer is of the form. So for some integer m, okay, every even integer of the form, either is it m or m plus 1, 2m or 2m plus 1. So let us begin with understanding what are those even integers. So even integers are 2, 4, 6, 8, 10 and so on, right? Now 2 is nothing but we can write 2 as 2 multiplied by 1, correct? 4 I can write it as 2 multiplied by 2. 6 I can write it as 2 multiplied by 3. 8 I can write it as 2 multiplied by 4. So if you see, what are these 1, 2, 3 and 4? These are integers, right? These are integers m, right? These are natural numbers. So I can write 1, 2, 3, I can replace it with m, right? So it's 2m where m is 1, again 2m where m is 2, again where m is 3 and 2m where m is 4, right? Where m refers to an integer. So what are integers? You have both your positive integers and negative integers. So 1, 2, 0, 1, 2, 3, 4, everything, and minus 1, minus 2, minus 3, these are all integers. So every integer is of the form 2m. Okay, so the correct answer is C, right? You can write, therefore, every even integer is of the form, as you can see here, it's of the form 2m where m is an integer. Okay, so this is your first question of exercise 1.1. Hope you understood. Let's move on to the second question. So for some integer q, every odd integer is of the form, is it q or q plus 1 or 2q or 2q plus 1? So the same way, let's do it. What are these odd integers? Odd integers are 1, 3, 5, 7, 9 and so on. Correct? Now, how can I write 1? 1 I can write it as 2 multiplied by 0 plus 1. Okay, so 2 multiplied by 0 is 0 plus 1, which is 1. 3 I can write it as 2 multiplied by 1, which is 2 plus 1, right? 2 plus 1, which is 3. 5 I can write it as 2 into 2, 4 plus 1. Again, 7 I can write it as 2 multiplied by 3 plus 1. So here also 0, 1, 2, 3, these are all integer and the integer is denoted by q. So I can write it as, I can replace 0, 1, 2, 3 with the integer q. So 2q plus 1, right? 2q plus 1. So all of these odd integers, you can see that they are of the form 2q plus 1 where q is an integer. Okay, where q is your integer. Okay, so the correct answer is 2q plus 1, right? Now let me write a small note, okay, for all of you to understand. It will really help you. So whenever you have any number, okay, they are of two types. One is your even numbers and the other one is your odd numbers. Always remember, even numbers are of the form 2m where m is an integer, and all the odd numbers are of the form 2m plus 1. So this is very, very important. Do make a note of it. Okay, even numbers are of the form, or even integers are of the form 2m, and odd numbers or odd integers are of the form 2m plus 1. Okay, so this is extremely important. Let's move on to the third question. The question is, n square minus 1 is divisible by 8 if n is an integer or a natural number or an odd number or even number. Okay, now n square minus 1, we have to check if it is divisible by 8. Now let us try with different values of n. Okay, and let us see. So when n is equal to 1, okay, when n is equal to 1, what is n square minus 1? So you can write 1 square minus 1, which is nothing but your 0. For n equal to 2, it is nothing but your 2 square minus 1, 4 minus 1, which is 3. For n equal to 3, it's 3 square, 9 minus 1, which is 8. Right? N equal to 4, again 4 square, 16 minus 1, which is 15. For n equal to 5, let's stop with 5. Okay, so 5 square minus 1, 25 minus 1, which is 24. Right? Now if you see, do you think every integer, if n is an integer, that means all of these should be, so this is not the right answer, because 2, 3 is not divisible, isn't it? So not every integer is divisible by 8. So this is not the, is every natural number divisible? No. You see 3 here, you say 15, 3 and 15, they are not divisible by 8. So natural number, again, it does not satisfy. Every n as a natural number, it is not divisible. You don't see it divisible by 8. The third one, odd number. If you see odd number 1, it's 0, 3, it's 8, and 5, it's 24. So all of these are divisible by 8. Okay, these numbers are again even number, no, not divisible. So the correct answer is it's only for your odd, only for your odd integers. So 0 is divisible, 8 and 24. So it's only for these odd integers that you can see for n equal to 1, 3 and 5. You can see that n square minus 1 is divisible. Okay, it's not for all integers, but specifically only for odd integers, that is n equal to 1, 3 and 5. You see that the given expression n square minus 1 is divisible by the number 8. So that's your answer. Okay, moving on to the next question. The fourth question. The question is, if the HCF of 65 and 117 is expressible in the form of 65m minus 117, then the value of m is 4, 2, 1 or 3. You have to check it. Now first of all, let us find what is the HCF of 65 and 117 by doing prime factorization. So let's do the prime factorization of 65. You have to find the prime factorization of 65 and 117. So for 65, let's begin with 5. 5 ones are 5, 5 threes are 15 and 13 is an odd number. So this prime factorization of 65 is 3 multiplied by 13. Okay. Again 117. Let's do the prime factorization. So 3 threes are 9. 27, 3 nines are 27. Okay. So again 3, 13. So this is nothing but 3 square multiplied by 13. Right. So I'm going to add, I'll make sure the factors are common. So I'll add a 3 raised to the power 0 here and 5 raised to the power 0 here. Now, the HCF of 65 and 117, we'll have to take the lowest power of the common factor. Okay, lowest power of the common factors, common prime factors. Okay, so here, what is the first prime factor? Let's take 3. What's the lowest power? 3 raised to the power 0. For 5, what is the lowest power? 5 raised to the power 0. So any number raised to the power 0 is 1. And what is the other prime? It's 13. Both the cases, it will be 13 raised to the power 1. So the answer is 13. But you're not asked, this is not the answer. What are you asked? If the HCF of 65 and 117 is expressible in the form of 65m minus 117, then you have to find the value of m. So this is equal to, this expression is equal to 13. Let's do it. So 65, you are given 65m minus 117 equal to 13. So 65m is equal to 117 plus 13, which will give you 0, 130, 130. Right? 65m is nothing but 130, and m is equal to 130 divided by 65, which is 2. Okay, so your m equal to 2. That's your answer. Okay, and this question is very important. It has been asked in the previous year's paper. Okay, so this question is very important. Let's move on to the next question. Yeah. The largest number which divides 75 and 125, leaving the remainder 5 and 8 respectively. So the minute you see that you have to find a number which divides 70 and 125, leaving the remainder this. So the number minus the remainder, 125 minus 8, you have to immediately, the first thing that you have to do is you have to subtract the number from the remainder. So 70 minus 5 is your first number. 125 minus 8 is your second number, whose HCF you have to find the largest number. Right? 70 minus 5 is 65. 125 minus 8 is 117. So in the previous question, we would have done the prime factorization of both. Right? So let's write that. So 65, the prime factorization is nothing but 5 multiplied by 13. 117, it is 3 square multiplied by 13. Right? If you have to find the HCF, the answer is the same as the previous question. So HCF of 65 and 117 is nothing but 13. It's the same way that you have to do, unlike the previous question. Same factorization. Okay. So the answer is 13. Let's move on to the sixth question. Yeah. If two positive integers a and b are written as a equal to x cube y square and b equal to xy cube, where x and y are prime numbers, then you have to find the HCF of a comma b. Very easy question. So let's write what is a. A is x cube into y square. What is b? X into y cube. Right? So what is the HCF of a comma b? You have to take the lowest power. Let me write it here. Take the lowest power of the common factor. So what is the lowest power of x? It is x raised to the power 1. And what is the lowest power of y? It is y square. So the HCF of a comma b is x into y square, which is option B. Okay, so it's a very easy question. Let's move on to the next question, seventh one. Yeah. So if two positive integers p and q can be expressed as p equal to a b square and q equal to a cube b, where a and b are prime numbers, then the LCM of p and q. So let's write what is given. So p is equal to a b square, q is equal to a cube b. So your LCM of p and q will be equal to, whenever you have the LCM, you have to take the highest power of all the highest power of all factors. Okay, so what is the highest power of a? It's a cube. What is the highest power of b? It's b square. So a cube b square, the answer is C. Okay, answer is C. A cube into b square. That's your right answer. Let's move on to the last question, the eighth question. Yeah, the product of a non-zero rational and an irrational number is it always irrational, always rational, rational or irrational, and 1. So suppose you have a non-zero rational number, say for example 2. You have to find the product multiplied by an irrational number, which is root 3. So 2 is your rational number and your root 3 happens to be your irrational number. So when you see the product, it is, what is 2 root 3? 2 root 3 is also irrational. Okay, so always remember the product of a non-zero rational and an irrational number is always irrational. Okay, so this is something which you have to note. And let's go on to the next question. The least number that is divisible by all the numbers from 1 to 10 both inclusive is. What is the least number that is divisible by all the numbers? You have to find the LCM. Okay, LCM of all the numbers from 1 to 10. So whenever you have to take the LCM, what do? You have to take the highest power of all prime numbers. Okay, you have to take the highest power of all prime numbers. So for 1 is not a prime number. Okay, so we are not writing 1. 2 is the first prime number. So 2. What are the prime factors of 2 or when you factorize? It's just 2. 3 is a prime number, as such 3. 4, when you prime factorize it, you get 2 square. 5, again 5. 6, I can write it as a product of 2 into 3. 7, again a prime number. 8, I can write it as 2 cube. 9, I can write it as 3 square. And 10, I can write it as 2 multiplied by 5. Okay. Now, if you see here, your LCM, okay, LCM of all the numbers 1 to 10 will be equal to, take the highest power. For 2, what is the highest power? It's 2. Is it 2 square? See, look here. You have a 2 square, 2 cube and 2. So, what is the highest power? It is 2 cube. So 2 cube multiplied by, what is the highest power of 3? So you have a 3 square. So the highest power of 3 as a prime factor. What is the highest power of 3? It's 3 square. For 5, there is just a 5. Is there a 7? Yes, there is a 7. That's all. This is the LCM. So what is 2 cube? 8 multiplied by 9 multiplied by 5 multiplied by 7. Right? 8 5s are 40. So 40 multiplied by 9 multiplied by 7. 4 9s are 36. 360 multiplied by 7. So your answer is 2520 is the LCM. So the answer is D, 2520. Always remember, whenever you have to take the HCF, you have to take the lowest power of the common factor. If you have to take the LCM, you have to take the highest power of all the prime factors. Okay, so with this, we are we have solved all the questions of exercise 1.1 of your NCERT exemplar. Numbers exercise 1.2. The first question is, the numbers 525 and 3000 are both divisible only by 3, 5, 15, 25 and 75. What is the HCF of 525 and 3000? Justify your answer. So, you are given that both the numbers 525 and 3000, they can be divided by all of these numbers. That means they are divisible by 3, 5, 15, 25 and 75. What do you mean by HCF? HCF is nothing but the largest number that can divide both these numbers. So out of all these numbers that are given to you, 75 is the largest number that can divide both 525 and 3000. So therefore, HCF of the given two numbers is 75. Okay, so let's write that very clearly. So the way because you have to justify your answer. So HCF, or the highest common factor, is the biggest number, that can divide both 525 and 3000. So out of all the numbers that are given to you, the highest number that can divide the two are both the numbers is going to be 75. So therefore the HCF of 525 and 3000 will be 75. Okay, so you don't have to do any prime factorization of each of these numbers and then calculate 75 because you're already given. Okay, so based on the given information, we have to just know what is the actual meaning of HCF. So the largest number that can divide the two given numbers. So that was your question number 1. Let's move on to question 2. The second question is, explain why 3 multiplied by 5 multiplied by 7 plus 7 is a composite number. So before answering this question, we should know what do you mean by composite numbers. So composite numbers are those numbers that have more than 2 factors. So let me write it here. Composite numbers have more than 2 factors. More than 2 factors, and all those numbers which have exactly 2 factors, they are called prime numbers, right? Composite numbers are those which have greater than 2 factors. So now if you take here, the given expression is 3 multiplied by 5 multiplied by 7 plus 7. Okay, so out of these two terms, okay, take 7 common out. So you'll have the first term is 3 into 5 plus 1, which is nothing but 7 multiplied by 3 into 5 is 15 plus 1, which is nothing but 7 multiplied by 16, right? What is 7 multiplied by 16? 7 6 are 42, 2 4, 1 1 2. So this is a product, right? So if you, as you can see from here, right, the product, that is 1 1 2, is a factor of the given expression, right? 1 is a default factor. 1 is a factor by default, right? Because 1 is divisible by all numbers. 1 can divide all the other numbers. And then here you can see 2 more factors, which is 7 is a factor and 16 is a factor, right? So by default, for the given expression, you can see 1 is a factor, 7, 16, and the product, which is 1 1 2, is a, so you have more than 2 factors here. Okay, so here by default we are able to write down 4 factors. Okay, therefore it is a composite number. Therefore it is a composite number. Okay, so this is how you'll have to express it. And a similar question is there in the NCERT as well, exercise 1.1. And I have done that in one other in my NCERT solutions playlist. Please do check it out. So this is a kind of a question which is repeated in most of the must do questions, and it has come in the previous year's board papers also. So let's move on to the next question. Can two numbers have 18 as their HCF and 380 as their LCM? Okay, so what is given here? Can two numbers have HCF as 18 and the LCM as 380? Now we should know one important thing, that in order for any two numbers to have 18 as an HCF and 380 as an LCM, we should know that the HCF is always a factor of LCM. Right? What does it mean? It means that what does it mean? HCF can completely divide the LCM. HCF, it means that HCF can completely divide the LCM. Okay, so let's see if it is completely, if 18 can divide 380 entirely. So if we see 380 divided by 18, first let's reduce it, simplify it, divide it by 2. So what do you get? 2 9s are 18, 2 1s are 2, 2 9s are 18, again 190 by 9. 190 is not entirely divisible by 9, or 9 cannot divide 180 completely. Therefore, it is not possible. You can say that 18 is not a factor of 380. Okay, therefore you cannot have any two numbers. There cannot be two numbers that can have 18 as the HCF and 380 as the LCM. Is that clear? So in order for any two numbers to have any two numbers as LCM, if that has to be satisfied. So if you are given that there are two numbers, say x and y, Okay, and A is the HCF, B is the LCM. So for A and B to be HCF and LCM for any two numbers X and Y, A should be able to divide B completely. Okay, so A should be a factor of B. HCF should be a factor of LCM. So that is how you verify if A and B can be HCF and LCM of any two given numbers X and Y. If HCF is not a factor, if HCF cannot divide, unlike in our case, that means there cannot exist two numbers that can have the given two values as HCF and LCM. So this is another very a critical thinking kind of a question. So you should know two important things, that HCF is always a factor of LCM. This alone is sufficient, or you can write HCF should be able to completely divide LCM perfectly. So these are, the meaning of both these statements are exactly the same. You can just learn and understand any one of them. Okay. Exercise 1.3 of NCERT Exemplar book. The very first question is, prove that root 3 plus root 5 is irrational. So whenever you have to prove irrationality, the method that we use is called as contradiction method. Okay, so let's assume, the very first thing that we would write it, let's assume that root 3 plus root 5 is rational. Okay, so instead of, what do you mean by rational? Any number that can be written in the form of P by Q. Okay, now instead of writing P by Q, for simplicity, I am going to write root 3 plus root 5 is equal to A, wherein A is a rational. A is a rational number. Okay, that which means it can be written in the form of P by Q. Now let me keep root 3 on one side and take root 5 to the other end. Right? And then I would have to square on both the sides. Squaring both sides. So when I square both the sides, I would be getting root 3 the whole square is equal to A minus root 5 the whole square. So 3 is equal to A square plus 5 minus 2 root 5A. Okay, let me take 2 root 5A to one side. So 2 root 5A comes to the LHS part, and A square plus 5 minus 3 goes to the RHS. So now you have A square plus 2. Okay, so 2 root 5A. Now what is root 5 equal to? 2A goes to the denominator. So A square plus 2 divided by 2A. Okay, so if you take A is rational, right? If A is rational, A square will be rational multiplied by rational, which is also rational, right? So this happens to be rational. 2 is also rational. 2A is also rational. But root 5, we know that this is irrational. So irrational number cannot be equal to rational number. Okay, which makes, you have to write, which makes our assumption wrong. And what did we assume? We assumed that root 3 plus root 5 is rational. So this assumption is wrong. Therefore, root 3 plus root 5 is irrational. Hence proved. Okay, so this is how you have to do it. This particular method is called as contradiction method. Okay, so this is how you have to do it. Let me again explain it to you. So when you have to prove that root 3 plus root 5 is irrational, or it could be any two numbers in this in place of this, first we will assume that, let's assume that the given numbers are rational, and let's denote it by A, wherein A is rational. That can be written in the form of P by Q. Let's take any one known irrational to one side. Take the other number to the other side. So a minus root 5. You have to square on both the sides. So when you square root 3 the whole square, you get 3. A minus b the whole square, a square plus b square minus 2ab. And then you rearrange the terms and solve it to a way that in LHS you have an irrational, all the other terms are making up to rational. Rational by rational is also rational. So we finally conclude by saying that irrational cannot be equal to rational, which makes our assumption wrong. Therefore, root 3 plus root 5 is irrational. Please try this once, and this is a very good question. So next question. Show that 12 to the power n cannot end with the digit 0 or 5 for any natural number n. Always remember one thing, okay? The prime factorization of a number ending with 0 or 5 will always have 5 as a prime factor. I will write it down for you. The prime factorization, this is a point to be noted. Prime factorization of a number ending with 0 or 5, any number, okay, any number that ends with 0 or 5 will definitely have 5 as a prime factor in it. So when you do the prime factorization of any number that is ending with 0 or 5, 5 will always be one of the prime factor. Now, but what are you given? You are given 12 raised to the power n. You can write 12 as 4 into 3 is 12. 4 I can write it as 2 square multiplied by 3 whole raised to the power n. So when you open the brackets, so a raised to the power m whole raised to the power n is nothing but a raised to the power mn. Okay, you can multiply the power. So this is nothing but 2 square whole raised to the power n. 2 raised to the power 2n multiplied by 3 raised to the power n. Okay, so the prime factorization of 12 to the power n contains only 2 and 3 as a prime factor. It does not contain 5 as a prime factor. So 12 raised to the power n can never end with 0 or 5. So you have to write the sentence. Let me write it. The prime factorization of 12 to the power n does not contain 5 as a prime factor. Right? It's only 2 and 3 that you can see here. Therefore, 12 to the power n can never end with either 0 or 5. Okay. So, for any number to end with either 0 or 5, for any, when you do the prime factorization, 5 will definitely be one of the prime factor. And if you don't see 5, that means that number will never end with 0 or 5. Okay, you can try it yourself. Check it for 1000 or 100, right? 2 5s are 10, 0 again, 2, 25, again 5, 5. So 100, if you see the prime factorization, 2 square into 5 square, right? Yes, if you take 105, right? 3 3s are 9, again 5. Again, 5 7s are 35, right? See, 5 is one of the factor. Right? So similarly, any number which is ending with 0 or 5 will definitely have 5 as one of the prime factor. Okay? So do remember this. Let's move on to the next question. So this is how you have to represent this question. Okay? Let's move on to the next one. On a morning walk, 3 persons step off together and their steps measure 40 centimeter, 42 and 45 centimeters respectively. What is the minimum distance that each should make so that each can cover the same distance in complete steps? Now, so you have to understand this question first of all. So each of them, the step length of the first person is 40, right? And then the step length of the second person is 42 and 45. What is the minimum distance each should walk so that each of them can cover the same distance in complete steps? So the minimum distance, will this distance, that the number that is asked by you have to think whether that number is less than the given number. Can it be that the minimum distance that each one should cover is 30 centimeter? Is it possible that they have to cover 10 centimeter? It's not possible. So what you have to know is the required answer. The required answer is bigger than the given data. Okay, what is the minimum distance each one of them should walk so that they can cover the same distance in complete steps? So definitely the distance that they have to cover, even if their step count is 40, 42, 45, what is the minimum distance each one should walk so that they can complete the same distance in complete steps? So the given answer is definitely great. The required answer is greater than the given data. And whenever this is the case, you have to find the LCM. LCM of 40, 42 and 45. And how will you do it? 40, you can take the prime factorization. It is 8 5s are 40. So 2 cube into 5. For 42, right? 42 is nothing but 6 sevens are 42. So 2 into 3 is 6. 6 sevens are 42. Again 45. 3 square multiplied by 5. 9 5s are 45. Therefore, the LCM would be the highest power of each of the common factor. So let me make it common. Here it is 7 raised to the power 0. Here it is 2 raised to the power 0. Here it's again 7 raised to the power 0. Here it's 5 raised to the power 0. And here also it is 3 raised to the power 0. So I'm just making sure that the common factors are spread across, are uniformly available in all the three numbers. So for 2, what is the highest factor? It is 2 cube. For 3, the highest factor is 3 square. For 7, the highest factor is 7, highest power. And for 5, highest power is 5. Correct? So it's 8 into 9 into 7 multiplied by 5. So 8 5s are 40, right? 40 multiplied by 9 7s are 63. So 4 3s are 12, 25, 2520. The unit is centimeter. So they'll have to walk a minimum of 2520 centimeter. Why? Because the given data is in centimeter. Right? The given data is nothing but this is in centimeter. So the answer is also in the same unit. The minimum distance that each of them should cover, okay, such that all the three are covering the same distance in complete steps. That is 2520 centimeter. Okay, always make sure you identify whether the answer that the question is asking you, whether it is greater or whether it is less than the given data. Okay, the numbers that are there in the question refers to the given data. The value that you are asked to find, that is the required answer. Always understand this, that if the required answer is greater than the given data, go for LCM. If the required answer is less than the given data, go for HCF. Okay, so with this, it will really simplify the way you do word problems. Hope you understood. Let's move on to the last question. Prove that root P plus root Q is irrational where P and Q are primes. Okay, again, let's go with the contradiction method. So for contradiction method, the first thing is, let's assume that root P plus root Q is rational. Right? Then you will have your root P plus root Q. Let it be some variable A, where you have got A is rational. And rational means it can be written in the form of P by Q. Let us keep root P on one side, take Q to the other side. So A minus root Q. And then immediately we'll square on both the sides, squaring both sides. Okay, so you have root p the whole square equal to a minus root q the whole square. So p is equal to a square plus q minus 2a root q, right? A minus b the whole square. Okay, make sure, so this here, right, you have a root in this term, so make sure the root term is in one side. So I'll have 2a root q is equal to a square plus q minus p, right? P and q are all rational. Now let root q alone be left on LHS side. Take everything 2a to the denominator, so you have a square plus q minus p whole divided by 2a. Again, here if you see, each of this a square, we assumed a was rational, so a square is also rational, q is also rational, p is also rational. All of these are rational terms. Rational by rational is also rational. So all the entire RHS is rational. Okay, root q is irrational. An irrational term cannot be equal to rational term. You have to write, this is not possible. This makes our assumption. This makes our assumption wrong. Therefore, root p plus root q is irrational. Hence proved. This is how you have to do it. It's a very must question in your chapter 1. So a variety of this question exists in both NCERT and Exemplar to prove irrationality. So the whole of chapter 1, real number, involves only 3 topics. Predominantly 3 topics. The first one is your LCM, HCF, the fundamental theorem of arithmetic, and the word problems using LCM, HCF, and the last one is to prove irrationality. So these are the 3 main topics from which questions are normally asked, and you have to try and solve every question of NCERT and Exemplar. I think I have completed all the exercise problems of NCERT and Exemplar of chapter 1. Do check out the playlist. I will be continuing this series for all the other chapters, the next chapter being polynomials. If you like my video and if you are able to understand it, please do consider subscribing and do like, and please write a comment so that it motivates me. Thank you so much for your support. Happy learning. Thank you.